All right, let's get started. Good morning, everyone. I'm Mandy Hubbard. I'm a software engineer and QA architect from Austin, Texas. I've spent almost 20 years, not quite yet, leading quality efforts for software companies in industries ranging from fintech to big data to network management solutions. So I have a real passion for quality. I guess looking back, I recognize that I've always been interested in quality because when I took my first programming class at UT, that would be the University of Texas, go Horns, I was writing C++ and our teacher gave us 90 points if we implemented all the requirements, and we had to go above and beyond to get the other 10 points. Being the geeky student I was, of course I wanted all of them, so I turned in programs with dynamically sizable tic-tac-toe boards, even though no one really wants a tic-tac board that's over 3 by 3, and all sorts of ridiculous features to get those extra points. I had this one program I turned in. I was so proud. I had implemented extensive user input validation, error checking, and error handling, and it was rock solid, and I couldn't wait to get my teacher's feedback. I got it, and I got a 90. I scheduled time with my teacher and said, I don't understand why I didn't get a 90. She said, there's no additional functionality, no additional feature. I was floored that she didn't see building a reliable, robust application as being worthy of extra credit. So looking back, when I was first becoming interested in technology, I had quality at my core, and that is how I came to be involved with Jenkins. I recognize that being able to reliably build, test, and deploy your software is a fundamental part of quality. It allows us to set up gates so that we don't push products to production until we've passed our test, and we have a way to release software without manual intervention. So that's how I got involved with Jenkins, and I've been doing anything I can ever since. It's my second year at Jenkins World, and today I'm going to be talking to you about running Jenkins on Kubernetes. So both KK and Sasha talked about the evolution of Jenkins. And expanding on that theme, I'm going to be talking about how the way we build software has changed over the years, and specifically what that means for our CI/CD environment. I'll talk to you about some of the things I've done to try to optimize my Jenkins build agents, which has culminated in my journey to Kubernetes. So when I first started testing and building software, there was generally a single application. We all know about this. It's called the monolith. There's one application running on one server. Even if there was a database, it was generally on the same server. Then as I moved forward into my career, we started offloading some of our services. Maybe we had a database server on a different physical or virtual environment. And maybe we took one service and put it on its own. I know I was working for a company where we took our identity service and put it on its own environment and our main application on a second environment. So now we've got more independent services to build. And now, companies are spending resources to deconstruct their monoliths and distributed applications and redefine these with individual microservices. This has drastically changed the way we run our Jenkins builds. How many of you are using microservices? Okay, great. And how many of you have seen slides like this touting all of the benefits of microservices? We're all aware of these promised benefits. We want to deploy smaller changes more frequently, independently. What company doesn't want to do that? Because ultimately we're going to reduce the cost and we're going to drastically reduce the risk. But let's think about this. How many of these benefits can we actually achieve without a continuous integration and deployment environment? What does it matter if we have individual small repos and we can iterate quickly if we don't have a reliable mechanism to build, test, and deploy it? So having a functional Jenkins environment is more important than ever if you're running microservices. So I'm going to take a minute and let's talk about continuous integration. If you were at my talk last year, this slide looks familiar, but I really love it and I want to make sure we're all on the same page. In a continuous integration environment, every single commit goes through a set of tests before it's merged to master. So in my team, we use GitHub for our source control management system, which is represented by the white boxes. And of course, we use Jenkins for our build platform. So in continuous integration, we set up end-to-end bidirectional communication between our source control management system and between our build system. This is achieved with webhooks. Therefore, when a developer works on a new feature in a branch, let me stop and say we could have a whole talk on whether or not they should be doing work in a branch or pushing to master, but that's a different topic. So for the sake of argument, they're going to work on a very short-lived feature branch. When they're done with their development, they'll open a pull request, as it's known in GitHub. There are other names in other source control management systems. We call it a PR for short. This indicates that they would like to push that change into the master branch being the branch from which we release to production. Now, with the webhook configured, whenever this happens, GitHub is going to send a notification to Jenkins that a pull request was open. Jenkins is then going to check out, build, and test that pull request before it is allowed to be merged to master. What I love as a quality aficionado is I can lock down my repo so that merges can't occur until all of my tests have passed. I can put whatever quality checks I want. I can look for code coverage, performance, any types of tests you want. So this is continuous integration, where every single pull request is going to automatically trigger a build. So the next stage will be continuous deployment. Continuous deployment means that our code is always in a releasable state. It means if we make partial commits on new features, they're behind feature flags so that we can release that code to production without affecting end users. Once the Jenkins build is successful, it sends a notification back to GitHub, and now my button is green. And I failed to mention before, that is the screen in GitHub while that process is occurring. Once a developer clicks the Squash and Merge button, we're going to kick off another series of events. GitHub is going to send another notification to Jenkins, this time indicating that we've pushed to master. My Jenkins file is written in such a way that we take different actions based on whether or not we're building a branch for a pull request or whether or not we're building for master. We can run an additional battery of tests and so forth. And then the last step is we'll package, we'll test it, and we'll deploy it. And honestly, where you deploy it and whether it's completely automated or has human intervention involved is really the differentiator between whether you're doing continuous deployment or continuous delivery. Some companies may have regulations where they need only certain people to be able to authorize deployments, or maybe there's some coordination with other systems, so they need a manual step. But ultimately, that is the goal. So let's take a minute and think about this. Remember the slide where we're moving to microservices? We've gone from 1 B to 30, 40 Bs. Each of those Bs is going to be built at least twice for every single commit. So the total number of jobs that we are running is increasing, and the total number of times we're running those jobs is increasing. So when we combine microservices and CI/CD, we really end up with a whole lot of builds. So it's time to adapt our Jenkins environment to be able to manage that and to get out of the business of managing infrastructure so that we can focus on managing our code and deployment processes. So once we've moved from a single application architecture to a microservices architecture, we are changing the way we build. We can't get away with a single master anymore. We must migrate to using Jenkins agents. I'm sure most of you are using agents, but can I just get a show of hands? Is anybody not using Jenkins agents? Still building on master? That's totally okay. We're going to talk about my journey. And just like you, I started with all my builds running on master. I will tell you that I've never installed Jenkins on a physical or even a virtual EC2 instance. I came to Jenkins after containerization, so I've only installed the master in a Docker container. But I ran master, and that worked great. And then I needed to start managing my workload differently. So I created an agent. I put all the tools and language support I needed to build any of my services, so I didn't have to worry about where the builds occurred. And then when I needed more capacity, I just scaled it by replicating the entire big agent. I think this is what Kosuke called the Frankenstein Jenkins. I always call it the monster Jenkins. Sounds like we definitely were on the same wavelength with that. So that got really hard to manage. My applications had different dependencies, and I really wanted to simplify. So I moved to what I call my snowflake agents. I created an individual agent for every single one of my services, where each agent had only the tooling needed for a particular service or any service that met those dependencies. I could control versions of languages. It was much simpler to do builds. But then I'm working with idle agents that aren't being used as much, and that is typically a problem for business. So in an effort to optimize my efficiency of builds with cost reduction, which was obviously a big priority for my company, I finally moved my agents to containers. I did this in a few ways. First, I tried to install the Docker engine inside my master. That's typically known as Docker in Docker. There are pros and cons for that, mostly cons, but that's where I started. And then I learned how to mount the Docker socket from the host on which my master was running into my master containers so that when a build ran, I could launch sibling or sidecar containers running on the same Docker host right alongside my master. So then I tried, I'm just going to create a big EC2 instance that's simply a Docker host, and I'm going to configure that as a resource where Jenkins can launch all of my containers on that external Docker host. And then I was managing disk space where I had to keep the images cleaned up, and I might delete all of my images after a build, but then there were things that another build could have taken advantage of. Still, all of this, I'm in the business of managing infrastructure. That's not what I'm best at, and that's not where my passion lies. So the thing that I liked best is I changed my Jenkins agents to be simply Docker host. I used the EC2 plugin. I used an AMI that had the Jenkins jar running and a Docker engine and client running. So then when I spun up builds, Jenkins would create one of these Docker hosts, and then all of the definitions for building my application resided in a single Docker file using multi-stage Docker. And that worked for a while. But then I got curious. What's the big deal with Kubernetes? And so that's how I got to be here today, is I'm going to show you what I did to get Kubernetes running and get Jenkins running on Kubernetes, and hopefully give you some super accessible information that will allow you to try it yourself. Before we move forward, how many of you are running Jenkins and Kubernetes? Awesome. Do you want to give my talk? No? Okay. Well, I'm glad to see that some people are, and if you're not, that's okay. We can get there. When I first started trying to run Kubernetes, there were a lot of concepts that I wasn't familiar with. So I just want to get some language so we're all on the same page. In Kubernetes, we have the concept of a node, which is simply a virtual or physical machine that runs aspects of Kubernetes, the very software components that work together to deliver the Kubernetes service. And you can install those yourself, which is where I started, and it was very overwhelming. So I actually created my Kubernetes cluster on GKE, and it was very simple. So we have individual nodes. You have a master node and one or more worker nodes that service the Kubernetes cluster, which is the next piece. This is a logical abstraction, a way of referring to the master and worker nodes as the place where we want to perform our work. The next concept is a pod. A pod is the smallest workload in Kubernetes. It typically consists of one or more containers that live and die together. They share resources such as the networking and mounted volumes, and you replicate by creating multiple replicas of a pod across nodes. Now, our Jenkins master is going to run in a pod on the Kubernetes cluster, and then when we spin up ephemeral agents, we're going to have additional pods running on the same Kubernetes cluster as our Jenkins master. Now, in Kubernetes, a service refers to an abstraction that defines a policy by which you can access these pod resources outside of Kubernetes. So Jenkins is exposed as a resource, and I'm using an external load balancer to give it an external IP address so that we could look at it today. Now, the way in which I installed the Jenkins master on my Kubernetes cluster is by using Helm. Helm is a package manager for Kubernetes. If you've used APK, Yum, Chocolatey, Brew, it's the same thing, just it's for Kubernetes. So chart is the way you package your application so that Helm can install it on Kubernetes. I'm going to take a minute and just slip over to GitHub, and let's look at the Kubernetes format. If you want to install anything with Helm, you can go to github.com, Helm, and navigate and see all of, oh, you can't see that, can you? Uh-oh. Well. Well, this is fun. This is the one thing I don't have a screenshot of. Let's try this. Oh, that's even better. Got it? Whew. All right. So this is a Helm chart. It's simply a set of files in a GitHub repository. If you worked with Kubernetes, you'll recognize this format. You've got your typical YAML definition. And you can see it's highly parameterized. So when you do an install, you pass a set of values that are then injected into those templates at install time so that your installation is customized for your environment. So I want to show you how extensible this is. These are all of the parameters you can provide to install Jenkins. You have so much fine-grained control over how it's installed. Oh my gosh, are you overwhelmed? It's super overwhelming. Don't worry about that. You don't need to worry about any of those. It's filled with sane defaults that you can leave. So when I installed, okay, now I have to go back to this. You are really challenging me. Did we get it? Oh, come on. Oh, yes. Okay. Excellent. So I wanted you to see the big values chart because I saw it and I was completely overwhelmed. What am I supposed to enter for all of these values? I did a great tutorial by Vic Iglesias, who spoke yesterday. He has amazing content out there for running Jenkins on Kubernetes, for deploying applications to Kubernetes. And so with his tutorial, I was able to learn that I only really needed to add a few values. You can see that you can specify the plugins to be installed. You can give some information about the type of container you want to create, and you can give it a service account. So that's all it took, is specifying those values. But I don't want to oversimplify. These are the things I did before I installed Jenkins on Kubernetes. In the interest of transparency, you do have to do all of these things, but they are very simple. Again, the resources available for learning how to do this are simple. I did most of this work in, I'm not playing with that again. I did most of this work in the Google Cloud Shell directly in the Google console. You can also run it locally, and the steps to do it are specified in the documentation, so you can copy and paste the commands and tweak it for your environment. So you're going to need a network, you're going to need a cluster, you have to install Helm on your cluster, you need to grant some access so that Helm can actually create the containers, and Tiller is the server side of Helm. You'll also have to add permissions for Tiller, initialize Helm, and you're good to go. I know it seems like a lot. It's really simple. It took me about an hour to get this up and running. But like I said, I don't want to wave my hands and act like I just ran this one command. But once you get that far, installing, you just simply do a Helm install. I've specified the stable Jenkins Helm chart that we just looked at in that GitHub repo. And I've specified my values.yaml, and it will take only the values I specified in that file and override the defaults in the values.yaml that comes in the Helm chart. So at this point, I've created my cluster, set up my network, given the correct permissions to Helm and Tiller, and I've installed the Jenkins master. Now, there are just a few things you need to do to be able to start launching agents. Oh, and one other thing, you know when you install Jenkins, you get the default administrator account and password. It's super easy to retrieve that with a command in your gcloud shell from Kubernetes cluster. So once we get the master running, we'll need a credential set for the Jenkins master to have permission to create agent pods on the Kubernetes cluster. We'll need a cloud configuration so that the Jenkins master knows where to create those agent pods, what Kubernetes cluster. Then we're going to create a pod template for the agent, and that's going to be comprised of a couple of container templates, because remember, a pod is one or more containers that live and die together. So we need to specify those things. So to do that, I want to take you to Jenkins, which means we're going to have to go through this fun exercise again, but y'all know I can do it. The problem is I don't know exactly how I did it before. Come on.
Just keep pushing buttons.
Yep. Oh, hey, now I can't see it. What's that? Yeah, if someone has like suggestions, I'm totally exposed up here. I'm happy to try it. Oh, that's a start.
That's nice.
Yeah, that's just my desktop. But that's okay, we're gonna get it, don't worry. Let's try the other one. Nope. Oh, but now I can't see it. That's crazy. I mean, I can see it up there, but I don't know about you. Okay. Oh, okay, I have to do everything up here now, see? Come on. Ta-da! All right. Honestly, installing Jenkins on Kubernetes is way easier than that. I'm not kidding. Okay. So we're in Jenkins. I've already logged in with that default password. And the things that you're going to need to do is set up your credential set. I've got mine set up here, and I've also got my GitHub credentials set up. I don't want to go too much into it, but you would probably use the Google repository for your code. I did do some of that in my investigation, but I'm actually very new to using Google Cloud and Kubernetes, so my code's still in GitHub right now. And you just simply, when you add your credentials, there's a Kubernetes service account, and you select that, and it is able to infer what it needs from the configuration. And then I also created this Google service account for metadata so that it knew what APIs to have access to. So this is going to give the Jenkins master permission to create the agents on that Kubernetes cluster. So the next thing I had to configure is the cloud settings themselves. And remember, when I did the Helm install, the Kubernetes plugin was installed for me by default, which was great. And the values were also pre-configured with the values, the default values in the YAML file. So there really wasn't much to do. I just want to show you that in case you need to change it or you have a different configuration. I did select my credential set. And again, I just kind of want to look at how much you're able to customize. And then we talked about we need to create a pod template. So just like with any other Jenkins agent, you create a definition of the agent and a way by which to refer to that agent when you want to run builds there. So I called it SuperPod, and that's how I'm going to refer to it when I want to use it. SuperPod, I can add the containers I need to build my application. So if I'm building a Go application, I simply want to have a container with all of my tooling to build the binary, and then I will package that separately. I can just package it in a smaller image with just Alpine because I don't need to actually have any of the tool support. Now, one of the things that you will have is a default JNLP container. The latest Kubernetes plugin is supposed to include that. I will tell you I had to actually add that myself manually to get that working. But the JNLP container is what's going to actually run the Jenkins slave jar and provide the connectivity from the master to the pod. And then the other containers are going to be ones that you define. So if you want to play around with that, that's what you need to do to get it configured. Oh, yeah, I got it now. Okay, so now we've got credential sets, we've got a cloud configuration, we have a pod template that contains a custom container outside of the JNLP container. So how do we use it? In the Jenkins file, of course. For the pod, for the node, you simply specify the name of the pod, and then you specify in a container block the name of the container from the container templates that you define to indicate that the steps in this block should be run inside the container. That's how I'm going to build my binary. So that's fun, but this does not give us the software-defined Jenkins configuration that we all know and love. If you saw my talk last year, Disposable Jenkins, you know I really don't like configuring things through the UI. So luckily, I'll take you to GitHub now because scrolling through a pipeline is hard in a slide. Can you guys see this? So luckily, you can actually define all of the agent pod template information directly in your Jenkins file. Here, I've specified, just like I did in the UI, a pod with container templates inside, and you can specify all the same configuration options that you specify in the UI, and you can leave the same defaults if you want. Oh, there was one other way I was going to show you. If you're already comfortable with writing YAML for Kubernetes, you can also throw your YAML right here for your pod definition. So that's another option. And then the third way is, and this slide is not pretty, but I want you to see, you can put your YAML definition directly in your Jenkins file, and then you just open curly braces and everything else is the same. So you can configure it through the UI, you can configure it by specifying values in individual fields, you can add YAML directly in the UI, you can add specification using Groovy syntax in your Jenkins file, you can use YAML specification in your Groovy file. So what I want you to see is you can jump head first or you can take baby steps to get there. If you want to configure it through the UI to get started, that's a great way to kind of, not be overwhelmed. It's really easy to get overwhelmed by all of the configurations available, but really you don't have to do all of them to get started. So once I have that, do I dare build? Vic had trouble with his demo yesterday, so clearly the demo gods are not cool. But I'm going to do one and take that chance because I got my display to work, so I should probably go to Vegas. Okay. So, let me show you this. Oh, you can't see any of that. Okay, I'm going to do the command and then I'll show you before it's, too late. Okay. I can't make that any bigger. So you can see, if you can see, we've got CD Jenkins as my Jenkins master, and when I run my build, let's go back over here. It creates a pod. So here it's creating a brand new pod with the containers that I defined in my template, the Go container, and actually defined a Docker container as well. I'm really comfortable with building Docker images and pushing them to Docker Hub. That's how I've been building applications. So I wanted to start by building applications the exact way I was accustomed to. So I mounted the Docker socket, and I used a container that had a Docker client so that I could run the Docker build commands. But you would also, there are gcloud containers, images available so that you can use the gcloud tooling. There are containers for the AWS SDK, the Azure SDK, wherever you're building, you can take advantage of their SDKs, which wrap all of the Docker commands you need. And yeah, I totally sympathize with you, Vic. This is not happening today. I'm going to take a move out of his playbook, and we'll look at the build I ran this morning like 20 times with no problems. So you can see here when it starts up, it's provisioning a new agent from the template, and you can see the default JNLP container, the Golang container, and the Docker container. And then once the build completes, that pod's going to die, free up your resources. Now you may be saying, well, I don't want to incur the cost of spinning up a new pod every time. Just like with other types of ephemeral Jenkins agents, you can tweak that setting so that if you have rapid succession of builds, you can use that same agent and only kill it once it's been idle for a certain amount of time. So I'm strictly reiterating what I started with. Things are changing. We have to change. You've heard that message. It's been a thread through this entire conference with keynotes from all of our thought leaders that the way we're running Jenkins is changing. And Jenkins capabilities are growing, but you have to make sure that you're growing your processes to take advantage of all of those capabilities. And I want to empower you to also try spinning up your own Kubernetes engine and getting the Jenkins master and agents running. I'm going to hang out at the contributor booth, which is right out here, sometime this afternoon after lunch. If you want to come and see the Jenkins master running on Kubernetes and look at the pods and cluster and all that kind of geekly stuff, you can come by. If you want to try it yourself, bring your laptop and we can run through it together. If you are really in the conference and you want to try this when you get home, say hi, find me on GitHub or Twitter or LinkedIn, and I'm happy to help. I had never run Kubernetes 4 weeks ago when I started this project, and the documentation was sufficient enough that I got it running in about an hour, and I spent about a weekend digging in to understand the concepts. And I really want to make this accessible to everyone so that you too can do that. Don't wait until your company decides to run on Kubernetes. Get ahead of the curve and be ready when they're ready, because you know they're always going to be behind us in this room. All right, so that's what I got. I'll leave that up. What are your questions? Yes?
Did you do anything around securing your tiller account for Helm?
I'm going to say probably. I'm not a Kubernetes expert. I've entered into this because I am super comfortable with Jenkins. But I'm certain that there are other ways to secure differently without using, say, the default account if you want to try and secure that differently. And I don't know if you've listened to any of the Jenkins X talks, but they're actually doing Helm installs that are tillerless. I'm looking forward to looking at the code to see how they're doing that, and that might shed some light on that. Yes?
Just as a side note, they're also trying to work it out with Kubernetes plus Helm, and we're running the tiller inside our namespace, but we're trying to externalize it outside of it, possibly running in a Jenkins. We were thinking, but like for Jenkins running inside a Kubernetes environment, having the tiller namespace on another Jenkins will be kind of complex. But so, have you tried externalizing the tiller actually outside of the namespace?
No, I haven't tried that, but that's a great suggestion. Sam.
So I have not worked with Kubernetes, but I am an extremely advanced Jenkins user. When you were starting your journey with Kubernetes, what was like the first document that you read that I can maybe look at as a beginner that kind of gave you an aha moment of getting started?
I have a resources slide somewhere that there it is. And I'm going to post this on GitHub later today after I clean up some slides I decided to toss at the last minute. Anything by Vic Iglesias is brilliant. What I started with was the Kubernetes documentation, and I was bogged down by the difference in kube control and kubeadmin and all the moving parts. And I spent time over the course of a few months trying to get motivated to read those docs for starters. They're very specific and technical about the inner workings of Kubernetes. And a lot of developers complain about, they don't really want to know the details of their infrastructure. They're there to build software. Likewise, I was there to run Jenkins on Kubernetes. And it was only once I found Vic's documentation that it took it up a level and made it accessible to me. And I created my cluster on Google Kubernetes Engine and realized you don't have to know all of those tiny pieces. So I suggest you start with this, make it work, don't ask too many questions as you go, and then come back and fill in the blanks. Because I found that if I tried to understand all of the low-level details up, it wasn't that interesting. But once I got it running, then I had the context to really understand those details better, and now it's just a matter of filling in information. So that's what I would start with. Yes?
So, for the master, how do you deal with like the LDAP configuration, for instance? How do you manage to put that into a Docker file? Or
That is a great question. So I know how I've done it in the past, and I know that one of the things that the Helm chart includes is the ability to run a startup script. This is the theoretical part. Normally when I speak, I only talk about things I've actually done because I'm just a super transparent person, and I don't like to talk about things that I haven't actually seen working. But here's what I'm thinking I might try. Well, first of all, we have we have Jenkins Config as code, which I'm going to be looking into using sooner rather than later. But all of that information is stored in config files, and I've done things where before the container was fully functional, I would run a script that would go and inject data into the configuration files, and I'd read that data from environment variables, which you can absolutely do with Helm install, so that once it came up, I'd injected my data at install time, and I was already authenticated with LDAP. In this instance, I didn't really get into the full configuration, and I just used the default administrator account, but there are definitely ways to do that, and I'm just going to be heavily involved in learning about config as code because I don't like to have to configure through the UI either.
yeah, that's fine, because we have Jenkins integrated with things like Splunk and Jira and LDAP, and those are the parts that I was trying to figure out how to make that a part of
Right. Well, and one thing is when you create a Jenkins master using Helm, it creates dynamically provisions a volume and a volume claim so that you have persistent storage. So it might even be a situation where you configure it once and then you reuse the same persistent volume on subsequent containers. But that is a subject that is very near and dear to my heart, so I'm going to be looking into ways to do that going forward. So feel free to reach out. I might have more information as I have more time to look into it. Yes?
My manager is interested in stability, and I was wondering if you had a Jenkins master writing to a persistent storage, done something to blow up the master, halt it, abort it, whatever, and then try to recover or come back. Is that a use case you pursued, or just not the right question to ask?
It's a fine question. It is not a use case that I pursue with Kubernetes, but again, I talked last year about Disposable Jenkins, where you blow away your master and bring it back up fully configured. So it is definitely right up my alley, and it's really in line with his question and something that I'd like to try. And now that I'm not under pressure to deliver a presentation and I can do this for fun, we should talk and connect, and I can try it and give you feedback. And you know, it's all about solving problems together. I don't think anyone has the answer. It's just a matter of working together and trying different solutions and saying this worked, this didn't work, and solving it together, and then blogging about it so that other people can find it. So I'm going to do a follow-up blog after this presentation on the Jenkins community site. So maybe that's something I can look into. Yes?
So does a does a Jenkins master have to run inside of Kubernetes, or can it be external to that?
It can be external. It would be an entirely different setup in terms of giving it permission. I know that with Jenkins running on the same cluster, it can infer a lot of information based on the fact that it is running on that cluster. But I don't like to say things I haven't done, but I'm fairly certain based on what I understand that you can configure Kubernetes for the agents without actually running your master there.
Sweet.
Yeah. Yes?
What would you say was the biggest advantage with your switch to Kubernetes?
Well, I'm not really managing agent infrastructure anymore. I mean, if you go through all the things I've tried before I got to this point, I was doing a lot of things. Even when I was running the Docker host, I had to tweak the AMI to have both the Jenkins war file and also the Docker engine and a Docker client, and I literally didn't have to do any of that. I can use any container I want. One other thing I could go on and on about the things that I've tried. One of the other things I did is I created my own Docker images with an SSH connection with the master for all the languages that I wanted so that I didn't have to deal with JNLP. So, and then I'm maintaining images and I'm dealing with, public and private keys between the master and the agents. I didn't have to do any of that. I can use any container I want, and it's very, very seamless. So that's the advantage for me, because if someone comes tomorrow and says, how long will it take before I can build a Node application? An hour? Minutes? That was huge. Yeah.
I can see an ancillary benefit to your point there, where you can use whatever Docker image you want, that it's very simple for a developer to pull down that Docker image that's used in the CI system and debug what's really wrong with their build.
That's a good point. I haven't tried that yet. I don't like my agents to die immediately when a build fails. So I'd like to play with configuring it where it dies immediately only if the build is successful, because you're right, you want to poke around and see what happened there. But that is a good point. Sorry. Yes, sir.
Just a question on on your build nodes, killing them after success, say. You were talking about maybe leaving them up if you had successive builds going. I use the EC2 plugin, and if I do dynamic build nodes, there's a certain number of minutes it takes
Right.
to come up. What's from your experience, have you seen a difference or a shorter amount of time in pods coming up?
Well, definitely, because it takes, I'm not really good at estimating time. I don't know, a minute or two to spin up that pod. So if you had it only kill the pod if it was idle for 15 minutes or whatever works, then you're going to definitely buy back time on subsequent builds to not have to spin up that pod, not to have to incur that cost every time. Sorry, you had a question?
So Kosuke talked in the keynote yesterday about cloud-native Jenkins that will run on Kubernetes. How will that help this deployment process?
That's a great question. We actually have different flavors all running on Kubernetes, because we have Jenkins X that runs on Kubernetes, kubectl, which is the Cloudbees offering running on Kubernetes, Cloud Native Kubernetes, which I think is optimized for deploying applications to Kubernetes.
It's for running Jenkins on Kubernetes.
Yeah, I picked the Jenkins X track at the Contributor Summit. I had Cloud Native Jenkins, Jenkins X, Config as Code, and Evergreen. They're all interesting, and I stopped at the Jenkins X table and I spent an hour talking to James Strachan about all the wonderfulness of Jenkins X. So I didn't make it to the Cloud Native. So I can't answer that, but it's something I'd be interested in getting back to you on. Anything else? Okay, oh yeah, sure.
When you spin it up and it completes, can other builds leverage the same pod that was spin up and more means of saving time? Because it takes quite a while to spin up a pod.
Right.
1 or 2 minutes.
So the question is pretty much the same question as this gentleman asked, is can you reuse an existing pod? And it doesn't really matter where you're running, because the termination of the pod is handled in the plugin itself, so you can configure the plugin to allow X number of minutes idle before it kills the pod. So if you know that you're building, every X minutes, you can tweak that so that you can reuse the pod. Now, that being said, the benefit of spinning up a new pod is you always have a clean build environment. And there's a trade-off there, but you could tweak it regardless of where you're running Kubernetes. Increase it if you want to. And you have to, well, we can talk more after. There's also options. You have to tell it if you want to keep the pod and then give it a time. Like the default is never to keep the pod, so you have to change the setting in a drop-down menu, and then you'll give it the idle timeout. Yes, sir?
Well, on that track, how long does it take to spin up a pod?
As I was saying, I don't know. I'm not good at. You know what? Let's go look.
Benchmarking, it's typically around 2 minutes, mainly because if your image doesn't have preloaded jars, then it has to load all the information that your pipeline's using in the agent. So that's
No timestamps in my Jenkins log, but
yeah, you can pre-bake some of the side loading to improve time. There's a great talk by Jesse Glick and Oleg yesterday that you can check out in recordings. They talk about all of that performance.
You can also use maybe a cache NFS in your images to improve that time, so that you're not full all the time. That may help.
Well, we're out of time, but I'm always happy to chat. I'll be in the contributor booth, and I'm online, so find me. Thank you so much for coming.